Hello, welcome to Just Learn Civil. In this tutorial, we will be learning about datum transformation using free software. We'll be transforming, for example, WGS 84 to Everest 1830. Everest 1830 is a local datum and WGS 84 is a global datum. We will be using free software for this purpose. In this video, it has been divided into 5 chapters. The first is terminology, then we will have projection and transformation flowchart, then projection parameter, chapter 4 will be transformation parameter, and finally we will be using the software. Let us start with the terminologies. The first one is geoid. Geoid means if you join all the points of equal gravity on Earth, then what you will obtain is the geoid. And ellipse is the reference model. Like if you remove all the points and if this is the geoid, then it doesn't have any fixed mathematical equation, so we need to approximate it by giving a mathematical equation, and the process of approximating is the reference sphere, that is the ellipse. This is the geoid and ellipse is the mathematical equation that defines the smooth surface of the or approximates the smooth surface of the Earth. Example of ellipsoid is WGS 84, Everest 1830. These two have mathematical equations so that we can find any locations by using the equation. But geoid has no such mathematical equations. And if you combine this geoid and ellipsoid, you will get datum. Datum is the combination of geoid and ellipsoid. We have two types of datum. One is global datum, another is local datum. If this is the geoid, then local datum means suppose a country lie here, then ellipsoid is drawn such that the country fits only this place, only this location, then that is local datum. But if ellipsoid is drawn so that it fits all the Earth, then it is global datum. In this figure you can see here, the gray color is the geoid and the red color is the global datum and the blue color is the local datum. You will find more error here in the blue datum because it is local datum only, it fixes here, so it solves the problem of only one location or one country. That is why it is local datum, accurate for local works only or local positions only. But global datum is accurate for all over the world, so GPS uses the global datum. GPS uses the global datum. WGS 84 is the latest global datum. Also, global datum is geocentric. Geocentric means it aligns with the center of the geoid. Now let us understand transformation. Transformation means WGS 84 is the global datum and Everest 1830 is the local datum. So if you want the data of WGS 84 to be transformed to Everest 1830 or any other local datum, then you need to use the process of transformation. It is like code. The WGS 84 is also latitude, longitude and height. Everest 1830 also has latitude, longitude and height, but 27 degree in WGS 84 is not the same as 27 degree in Everest 1830. It may be 26.5, 26.7, anything else. And for the purpose of transformation, we will be using 7 parameter transformation. Now another is projection. Projection means converting 2D map, 3D map, converting the 3D Earth into 2D map. This is a projection. So we have two things. One is transformation from one datum to another, and another thing we have is projection, converting the local datum to the or global datum to the 2D map. Universal transverse Mercator is one of the most widely used and it is a cylindrical projection system. 3D Earth is transformed to the 2D map. So while converting this, we may have either area distortion or the shape distortion. Then we have UTM. UTM is the Universal Transverse Mercator, that is the projection of datum to the 2D map. It has divided the Earth into 60 zones, each of 3 degree. So to find the zone and the central meridian of any region, you can use this formula. Zone is equals to central meridian plus 180 plus 3 is all divided by 6. So here you can see in the figure, you have two zones, 44 zones and 45 zones. This is where Nepal lies. So you want to find the central meridian, then you can put the value in the formula and you will get the zone. And conversely, you can also find the central meridian and zone using the formula. And MUTM is modified for Nepal only. Here the zone is divided into 3 parts. And previously it was only 2, now it is 3. This 84 is the new central meridian. And it has no such formula as above to find the central meridian and zone. You can convert, let's say here, now terminology is related to height. Orthometric height is the height above the geoid. So if you measure any terrain, the terrain can be mountain or the height of the building or anything else. If you measure it above the geoid, then it is called orthometric height. If you measure it above the mathematical smooth model, that is ellipsoid. Ellipsoid means WGS 84 or Everest 1830, NAD 73, etc. whatever datum it is. If you measure above the datum, then it is ellipsoid height, and the difference between them is the geoid separation. When you use WGS and you get the height, then what you are actually getting is the height above the ellipsoid, and what you actually need is the height above the geoid. So you will have to add or subtract the geoid separation of that location. Chapter 2, Projection and Transformation Flowchart. So this is the flowchart we will be using throughout our tutorial and throughout the uses of the software. If you have WGS coordinate and you want any local datum coordinate, for example, we have used Everest 1830, then what you need to do is use the transformation module. The transformation can be of various types. We will be using 7 parameter transformation. So the first thing you need to do is convert WGS 84 coordinate to Cartesian coordinate, that is XYZ coordinate. WGS 84 is like a polar coordinate where we have angle and height, and WGS 84 Cartesian coordinate is like XYZ coordinate. It is still the same thing. It is not projection system. It is just the conversion to the XYZ or Cartesian coordinates. Then you transform the Cartesian coordinate to Everest 1830 Cartesian coordinate using the 7 parameter, and then convert the Cartesian coordinate to WG datum coordinates, that is Everest 1830 geodetic coordinates. And finally, if you want to do the projections, then you can project WGS 84 to UTM and Everest 1830 to MUTM. So we have two modules here. One is for transformation, the above one is for transformation from WGS 84 to Everest 1830, and the another is projection. Here we have projection 1 and we have projection 2, but the formula for both projection is same. So that is, we have three process for transformation. One is convert to Cartesian coordinate, transform it to Cartesian coordinate of another datum, then again make it the Cartesian coordinate to the geodetic coordinate of that datum. The transformation equations used here is as shown here. Suppose this is the coordinate of WGS 84 and we need the coordinates of geodetic Everest 1830, then this is the non-coordinate to be used here. and we have the 7 parameters. So coordinates of datum B is equals to transformation parameter and uses of coordinates of datum A, where the 7 parameters are dx, dy, dz. These are the translation factor. Then we have rx, ry and rz. These are the rotation factors. And then we have scale factor. And finally, when you use the non-coordinates, then you will get the value of unknown coordinates as in here. And once you have this is only done in the Cartesian coordinates. So transformation is only done in Cartesian coordinates from one Cartesian to another. And you will have to convert this Cartesian coordinate back to the geodetic coordinate, and this is also converted from geodetic to the Cartesian coordinate. So what you actually do is the process as mentioned above. Chapter 3, projection parameters. So as on here, we have two projections. You can project WGS84 to UTM or Everest 1830 to MUTM. Now you have the projection parameters, that is the projection is done in UTM. Put the zone, which coordinates lies in which zone you can find, and then input the zone. Then you have the semi-major axis of the datum and flattening factor of the datum. Then you have the k naught, m naught, phi naught. These are the parameters of the projections, that is Mercator, universe transverse Mercator parameters. And here you have two parameters that defines the datum. We will be needing this for transformation. Similarly, for MUTM also, you have these two parameters that defines the datum, the flattening factor and the semi-major axis. Now transformation parameters. You have the transformation parameters for WGS84, that is semi-major axis, then flattening factor, angular unit and prime meridian. The 7 parameters are listed in the text file of the software. So the first part consists of the parameters of from datum. So if you want to convert from WGS84 to Everest 1830, then from ellipsoid is WGS84. And you have to enter the major axis A1 data of the WGS84, flattening factor of the WGS84 without distorting the format. You just need to change those numbers. Then at last you need to enter two ellipsoid, that is the parameters of two ellipsoid. You want to convert WGS84 to Everest of Everest 1830, major axis and the flattening factor. Then finally in between you have to enter the 7 parameters. The 7 parameters means dx meter, dy meter, dz meter. These are the translation factors. Then you have rx, ry, rz, the rotation factor, and finally the scale factor. Once you have entered this data, then you can use the software. And remember, the 1830 data has already been input here. For other local datum, you can input accordingly. The transformation parameters are found from the survey department. So for different local datum, the transformation parameter will also vary. Input the text in the file as per your datum of interest. Now finally we will be using the software. The software has two modules. One is the projection module that has already been covered in the previous video. Put the link in the description. In this video we will be doing the transformation module. So the transformation module will follow the method as mentioned above. First we will convert the geodetic coordinate to Cartesian. Then we will transform the Cartesian coordinate of datum into datum B. Then we will again reverse it back to the geodetic coordinate. And finally we have the transformation module that will give us the coordinates from one datum to another datum. And if you need to use the projections, then you can use this module, which I have already covered in the previous video. These are the test data. You can use this test data to convert. So let us start the software using. You can download the software from the link will be given in the description. Then go to repositories here. Then scroll down and you will find CSAY lat long UTM from to converter. Download the zip file, and once you have downloaded the zip file, you will extract it. After extraction, follow this process and then finally go to bin. Then you will have a debug folder, and inside the debug folder you will have CSAY lat long converter.exe, that is the application. So you have to click this and open the software. I have already copied, and you can also copy and paste this debug only file to somewhere else locations. You don't need all those other files. So I have already copied this, and here I have the application. .exe is the application. Then double click to open it. This is the projection module. We will be using the datum module. Datum module can be found in file datum transformation. So the first step is click file and then go to the datum transformation. Now here you will get the list of the text file that has already been inside the folder. You can see here the transformation folders, datum transformations. Here is only one text. If you want other text, then copy it and paste it, then rename it to whatever you want and change the data accordingly. WGS84 data is same for all over the world. The transformation parameter varies as per the local datum. Then enter the local datum data and you will have a new file. And to access the new file, you have to reload the software, then click datum transformation, and then you can see here you have two files. But we will be using WGS84 to Everest 1830. Now once you choose the file, go to file and click load datum parameters. The parameters has been loaded here. Has been from ellipsoid, then to ellipsoid, and finally the 7 parameters. Now the second step is just follow the import LLH. LLH means latitude, longitude and height. So while importing, you must have data saved in a text file, or you can simply click here and generate mode, and if you have manual data, then you can enter the manual data. Suppose I have two data, then 2 rows has been generated and you can use that as well. So here I will be using the import method. File, import LLH. I have WGS data, so I have imported it. Now you can also make a data in WGS. The format should be serial number, then latitude, longitude and the ellipsoidal height. Now once you have loaded the data, you need to do transformation. So here you can see here the geodetic to 3D Cartesian for datum 1. The first step is converting to 3D. The first step is converting WGS84 to Cartesian 84. Now the second step is 3D Cartesian transformation using 7 parameters. That is, now WGS84 is converted to 1830 Everest Cartesian coordinates XYZ. Now we need to convert this XYZ into Everest 1830. For that, we'll click the step 3. Instead, you can also click the auto process to convert all them at the same point, at the same location. After you have converted the data, you can export it to the Excel file. So you will have the Excel file where you have the input data, converted data, and the parameters that has been used. Now, if you want to do the projection, then you can use this latitude longitude of WGS for UTM or latitude longitude of 1832 MUTM. So MUTM will be converted, and then you will have the coordinates in the projected system as well, but you have to use the projection module. Now we already saw how to convert WGS 84 to Everest 1830. Now we will be converting Everest 1830 to WGS 84. For that, you have to follow the process earlier mentioned. First is to choose the datum. Remember, here I am choosing WGS 84 to Everest 1830, but I want to change Everest 1830 to WGS. So I will click here reverse transformation parameter. Now from ellipsoid has become Everest 1830, and to ellipsoid has become WGS 184, and the parameters has also been reversed in sign. Now I will load the file, but this time I will be loading Everest 1830 data. So I have the Everest 1830 data, and what now I will do is auto process all the 3 steps and then export to Excel file. So you can match with the earlier data we converted from WGS84 to Everest 1830 and vice versa. So this is the Everest 1830 data. Now I want to convert it to MUTM 84. Then what I will do is go here in the projection module, enter the data to generate one row, then input here the data, and this is the MUTM 84. So I will load the parameters. Okay. So MUTM 84 and load the parameter, but the zone is mistake here. We have to make it central meridian, and then file, load the parameter. Now we have the zone. Now convert it to latitude, longitude, and finally we have the coordinates in MUTM. So remember one thing, that if you want to convert UTM coordinates to MUTM, then you cannot directly convert here because there is no such line in the flowchart. So you have to always follow the flowchart. You have to first convert the UTM to WGS 84, then WGS 84 to Everest 1830, then Everest 1830 to UTM. If you want to convert WGS 84 data to UTM, then also follow the same process. Convert WGS 84 to Everest 1830 and then convert to UTM. If you have MUTM data, then MUTM data can be converted to Everest 1830 using the projection module. then Everest 1830 is converted to WGS 84, and then WGS 84 is projected to UTM. So always follow this flowchart line, so you cannot cross the flowchart line. In this way, you can use the transformation and projection module. Thank you for watching. Please subscribe, like, share, and comment for any further queries.